Hey, good morning. This is Brenesh, as lead solution architect from application modernization team within Wipro Digital. And I'm here to talk about mainframe modernization offerings, what we bring it upon, including the data migration and then the whole a lot of other nuances like, your application services migration and UI migration, right? So to start with, typically in a mainframe environment, right? What are all the major challenges which we see? Anytime in a mainframe environment, there are like 3 or 4 major changes. The time to roll out any new changes into production is like 6 months to 9 months, right? And then definitely most of the mainframe shops are starting using something like a fourth generation language, which is like a code converters, code generators, right? For example, Key, Netron, there are like Focus, there are like so many of them, and these are all not in scope right now. And then there is a heavy shortage of mainframe skills currently, right? And then the other things are everybody's moving towards cloud. So organizations are adhering towards a cloud native application and a cloud native solution. So these are like major things what we are seeing. And then if you really look at the opportunity, what we are talking about, even till date, most of the mainframe applications handles, core banking, core insurance, and core retail applications. That's what 71% of the top companies are still with mainframe, and it is amounting to 30 billion transactions per day. And if you really look at the 30 billion transactions per day, 80% of these transactions are predominantly inquiry transactions, be it account inquiry, customer inquiry, transaction history inquiry, those kind of stuff, right? And then, and we see a larger trend today that these inquiry transactions are shifting away from mainframe into a kind of a NoSQL or highly available platform, a database where it can seamlessly scale based on the needs. And these inquiry transactions are also contributing to more than 50% of the overall cost of this. So we believe from a mainframe modernization opportunity, shifting the whole mainframe workload where possible into a distributed cloud platform, into a cloud database. That is the first option. The second one, in case if the core of the work, which is the system of record, in case if it cannot be migrated, in case of a large banking or a record keeping scenario, probably offloading the inquiry transactions is a good idea, right? Moving that in mind, some of the typical changes, challenges, what we see from a mainframe architecture, right? It can be headless or it can be with the UI, right? So any modernization solution will have to address both the scenarios. And there are quite a lot of platform-based components which sits out in mainframe. And it follows a big logical chain of events like, your daemon program, router program, polling program, your maps and your programs are tightly coupled. There's quite a lot of screen scraping which happens because these mainframe screens cannot be rendered via green screens, right? A simple classical example is if it is in case of an insurance platform, if the core bank, if the core insurance platform is in insurance, the 3270 green screens will not be scalable for anything else. So what they do is they write a simple VB-based macros. It fetches the the statement number or it fetches the customer number, and then it go and query against the enterprise content management platform, takes out the history, transaction history, and other stuff, right? So it is a disjointed communication in this kind of cases. So we wanted to avoid screen scraping because we can enable services, data as a service, or even APIs today, right? So that is what it is. And then the last one, which I want to talk about, is about the data modernization, right? So today we see that most of the data is all in vSAM, IMS, DB2, and other stuff. But then we see a larger base of customers moving towards a cloud database, be it Aurora or be it Postgre or NoSQL, any other NoSQL database, including Yugabyte and other stuff, right? So there is a good traction of all this data modernization, which is independently happening. And then the last one is many of these mainframe transactions are stateful transactions. So they heavily use something like a temporary storage queue, temporary data queue, and other stuff. So we need to find a solution for each of those nuances. And this also has to be, need not be a a full-blown solution, but then a kind of a piecemeal solution where everything can be plugged and played according to the needs. For example, in some of the cases, it might just be a UI modernization. In some other cases, they might just be migrating the database out of it because the applications might be already out of mainframe, right? And then in certain cases, it might be the complete rewrite of your apps and screens altogether. So the possible solution, we have come up with a framework which addresses all these needs. I mean, we call this is our modernization framework. And if you look at it, we address it as a step-by-step kind of a process where if you look at it, the legacy Z landscape, we use any transcoding tools which just converts your COBOL to Java, right? And then when we look at it, it has a very simple plain HTML with nothing much of a screens, which I will shortly show it. And then the business logic layer, again, while in mainframe they are tightly coupled, it's the same thing given in the target landscape, right? I mean, just after transcoding. And that is where the data also, it is going to be a one-to-one model many a times. The data will not go for transformation. So that's where what we have created is a bunch of next set of services. For example, how do we generate microservices out of this? We have partnered with someone called vfunction, which can dynamically identify microservices from a runtime. And then if you look at it from a data point of view, a couple of things. First one is about the seamless conversion of your data elements, your objects, your indices, your stored procedures, on all those things from your legacy to the target landscape. So that's where Wipro as a company has something like SQL converter, which we have built on top of SQL lines. That comes in handy. And then the second one is, while this is on DB2 for ZOS, this is just going to be on DB2 for LUW without any code changes. Now, if you're looking forward to migrate it to a database like UGABIT, the sequence changes, right? I mean, so not all constructs in DB2 are completely compatible in UGABIT. For example, current space date may not be a valid syntax in a target database, right? I mean, so we have written another utility. What it happens is it's an application remediator. It extracts the sequels out of the current landscape, converts it into the target database, what we have defined, and that's how it comes. So just after taking microservices, we have a 4-step refactoring, what we do to completely make it into a microservices kind of model. And then the last one, which I wanted to talk about, is the UI builder. This is more like a kind of a low-code, no-code offering from Wipro, which helps us converting either the BMS screens directly into Angular screens, or it can also help us convert from any HTML, simple basic HTML or JSP pages into a full-blown Angular project itself, right? And then that's where Wipro leverages our own tools like integrated DevOps platform and our comparator tool, and then finally move to the target any cloud-based nuances, right? I mean, so that's what it is. And then quickly moving on to the next section of it, right? I mean, so the second major offering, what I spoke about, was about offloading your inquiry transactions out of this. So today, what happens is all the reads and writes happens in the mainframe. And let's say that this is with the UI, right? I mean, so everything happens through a 3270 based mainframe green screens, which caters to all the inquiry, add, maintenance, and everything. And this is like very tightly coupled to the business services, which are all written in COBOL and Kick screens, right? And then be it the database, be it like IMS or DB2 or anything of that sort. So now most of the banking, insurance, and other clients, we are seeing a major shift towards moving this database, especially for an inquiry transaction, into a NoSQL database, right? A highly scalable, a transaction-based database. The advantage of having this one, this table is especially in the third normal form. However, the data what we are trying to represent for a kind of a NoSQL database or a UGABIT, what we wanted to have is this is completely in the same JSON response what we give it back to the clients or to the channels. So the advantage is during the runtime, there is no transformation. It's all a pre-enriched data, which we sync it from the legacy database into the target using low latency sync, which can be a trigger based or it can be a Kafka queue based. So eventually we also wanted to get rid of the 3270 green screen. So we're all making every services in mainframe is API enabled. So the Angular screens out here are created using our UI builder, the low-code, no-code platform, which I spoke about. And then the business logic of only the inquiry services are existing in the target environment and which directly accesses the database, which is out there. And we see a huge demand for this. There are a couple of reasons, right? First one, to give a 360-degree view of the entire transactions. Most of the time, mainframe is all core, but then there could be a lot of peripheral applications which might also be feeding data back to the channels. So now, having data outside this creates a whole 360-degree view, getting data from mainframe, also from the peripheral databases, right? So during the runtime, your application performance is much faster, and we can stop most of the inquiry transactions, and thereby you can save the network hopping, as well as you can save quite a lot of MIPS cost in mainframe. And second one is this also enables quite a lot of caching with Redis or something else, or any other database-based transaction-based caching as well. This significantly improves your overall transaction performance as well as your costing. So because of that, what we see is this model is getting more and more relevant, right? As I spoke earlier also, the same transcoding tool, some customers actually go for a COBOL to Java conversion and then make them as inquiry API. But in some other cases, in case if you are taking out quite a lot of other systems as well, this might be more of a manual refactoring step. So that's where we leverage our analyzer tool, which automatically extracts your screen services versus your business logic services, and then it helps us carving out the inquiry API. And the same, the UI builder, which can be used to directly convert our 30 to 70 green screens into Angular. Now, the next one is the ZOS Connect. That's what I spoke. Exposing the mainframe services as APIs, right? So we do that, then again, leveraging the same analyzer tool, which I had. Now, DB2 or the data migration, right? The major part of it. So here, there are like 3 major tools which we leverage. It supports most of the NoSQL databases, including Guabite and all other relational databases as well. So if you look at it, the first one is about extracting the data elements or the data definitions from the legacy. We use like SQL converter. And then the next one is app remediation, which helps us extracting the SQLs, transforming it into the target, and then helps us remediating certain things like, your plain JDBC to Spring JDBC and those kind of stuff. And data loading are ETL based, which is like a completely configurable source to target data mapping based data migration tool, which can be used for the complete source to target data migration, right? And then the platform or the peripheral services are common across any migration for that matter, the comparator tool and the WID. So now, without not much wasting time, let me quickly get into the demo part of it. Okay, so this is the mainframe typical green screen, what you see, right? It's all like keyboard driven. You can see that, the menu and navigations, like, you have to, in case if you have to query for a name and address, this is how it is. So just after transcoding, if you look at it, the screen is exactly going to look like the same, except for, the colors being, transcoded. Right, in a mainframe green screens, typically when you look at it, right, it has to be completely, you have to remember each and every, application code, and then each and every things like what kind of actions which you have to take and all those things. And if you look at the current screen, what we're seeing, this is the transcoded application screen. This looks exactly same because it's a like for like migration. And you still have to remember the same kind of stuff. It is all completely keyboard driven. And the same, the function keys, what we generally use it in mainframe, they still appear here. So it's no way indifferent, right? So this is where the challenge is, again, the screens and the application business programs are tightly coupled. And then this is also not into a modern use case, which means, you cannot use your browser or anything to completely control it, right? So that is where the whole challenge is. So now let us show our modernize offering. So if you look at it, as I said, right, I mean, so any mainframe modernization will have to look from three major stuff: the UI, services, and the data transformation. So now let's quickly look at the data transformation, right? I mean, so the data transformation comes with two major tools in it. The first one is about the data extracting your DB definitions, right? I mean, so yeah. So here you may convert any source database. For example, DB2 to gigabyte. You can just select your source and the target accordingly, right? I mean, you just select, I mean, DB2 to gigabyte itself, and then automatically it connects to database. Okay, so before that, I wanted to talk about one more thing. In a typical mainframe environment, you may not even have your DDLs many a times, right? I mean, so we have an option to generate the DDLs. So which means it can go ahead and scan your COBOL programs, get the declaration generators, and get your corresponding table create scripts accordingly, right? I mean, so probably let me fast through it in the interest of time, right? And then the next option is if you have to do a schema migration from DB2 to, let's select, I mean, DB2 for ZOS to gigabyte, right? I mean, in this case, it automatically extracts the host information if you just give on it, right? And then here in this case, mainframe DB2, the connections are not open. So we can just, we will use the files which are created from the previous step. So which means the ones which are generated from your, DCL generators, right? I mean, so in this case, I mean, we have a setup for our PostgreSQL ready in our environment. So if you look at it, it directly takes this environment, connects to the Postgre, or for that matter, gigabyte, and then directly creates a table and then loads some data entries also right there. So when I say that data migration, this is predominantly meant for object migration and not for data migration. Data migration, we generally use it when there is a very little static data which needs to be migrated, right? I mean, so that is where we generally use it for data migration, or for a lower environment like a development environment if you have to migrate only a very little amount of data. So, but the major point what I wanted to make here is this, seamlessly helps us migrating from your database from your legacy to the target. Now the next thing, let's look at it, right? I mean, so which is about the SQL extractor. So as I said earlier, if you look at the SQL extractor here, the remediate application, what it happens is it just extracts any program that is corresponding to this, right? I mean, so it go and look at all the Java classes or the COBOL programs and look for the classes or the methods with SQL in it, and automatically extracts it and converts it to the target database. So here, the reason why we have given Postgre here is gigabyte and Postgre are like completely compatible. So that's why we have shown it. We can easily see, the moment on a click of a button, we can see that the SQLs are all extracted and getting created from any 340 program. So if you look at one of the SQLs, right? I mean, so the first one, current space date, it is definitely not a syntax in Postgre or gigabyte. It has to be current underscore date, right? And then yeah, so that's what we see it here. It gets changed. And also, if you look at it in mainframe, it's a common scenario is a row level locking anytime when you're trying to insert the data to maintain your data integrity, right? I mean, so when you actually look at it, here you can clearly see that, withhold off, and then you have all the fields, it's all being maintained here, right? I mean, as a row level locking. So, but then in the target environment, be it gigabyte or in PostgreSQL, you don't really have to give all the stuff, right? I mean, so just the holding the record is enough. You don't have to mention every field out there in the target. So similar to that, we have identified so many patterns. Again, what I said was like, this is written over and above the SQL lines utility, but then there are a few stuff which we have handled over and above based on our industry experience in mainframe modernization, right? So that is what you see it as a part of the, data modernization. So now let's quickly look at the services modernization. So the services modernization, as I said earlier, we are using a partner powered tool called vfunction. So the vfunction analyzes your data records based on the runtime, and if you look at it, it gives a different set of bubbles which helps us identify which are all the actual services. Here the bubbles means the exclusivity of it, right? I mean the white color bubbles says that the exclusivity is pretty less, and then the pink one says the exclusivity is pretty high, right? And especially most of the pink ones and other stuff, the copybooks and then the exclusive programs are all here. And then the size of the program, size of the bubble, right? It depends on the size of the number of functions in it, or the amount of CPU which is being spent on it. So there are like so much of play around which we generally do on top of it. It's like we control certain parameters, like how much time the CPU has taken. And if it is a third-party function, say for an example, if you're trying to leverage a elk function, or if you're trying to leverage something like a log4j, those are all like we generally classify them as infra functions or a third-party functions, and then the Spring Boot dependencies and other stuff. So by adjusting our dependencies, those things can be completely taken out. And if you actually look at the refined stuff, it is going to be pretty less, right? And then very, very little. And then as the next step, what we do is we look at the call tree of it. We can actually go ahead and explore the tree of it. And by exploring the tree, it gives us a complete path it navigates. And it also tells us, how many such entry points can be possible for this. And also, if you look at it, right, I mean, there are like different references. It gives what are all the potential entry points which we can make it as a rest endpoints, and what are all the actual entry points, and how many ways through which the same service can be triggered. For example, here in this case, it can be triggered via like two different options. This is an inquiry, I mean, maintenance function, but then it has like two entry points. The first one is just for getting an inquiry data before maintenance, and the second one is for the actual maintenance of the business function, right? I mean, so these are all some interesting facts which comes out of that. So we do some kind of manual analysis, and then we just go and extract the service definition. And then until now, just remember that the tool does not have access to the source code, right? So just after running it, it produces a good amount of microservices. I mean, more like I would call it as a mini services from the extracted business functions, right? And then we do some minor refactoring, and then we deploy the code. So now, in the interest of time, let's look at the UI part of it, right? So now we have looked at the servicing and the data. So now let's move on to the UI transformation. As I said earlier, the UI transformation helps us building new Angular screens or the React screens, as well as it helps us converting legacy UI, right? I mean, so in this case, it is more like a kind of a low code, no code platform where you can easily go and configure. And then anytime when there is a mainframe screen, or you have a converted Java screen, which is like simple HTML screens, we capture different widgets from it, right? I mean, so we capture different frames and load them as widgets. This widget is a pretty popular concept. So what we do is, right, I mean, so the widgets are like classified into three different categories. First one is your enterprise widget, second one is your domain widget, and third one is your app level widget. The enterprise widget is common to the entire firm, be it a bank or insurance, right? I mean, it represents your style guide, all your colors and stuff. And your application level widget is the one which is specific to this application. And then the domain level widget is, for example, within let's say that if it is a mortgage house, a loan origination could be a sub function, right? I mean, only things related to loan origin might be there as part of your application. And if you look at the left corner of it, there is a columnar, 12 columnar row, right? I mean, this represents, we can split your entire table, entire screen into different grids, and you can, you can partly load it, or you can fully load a gadget into a widget into that, right? I mean, so here I'm just trying to split my screen into three different, layout, if you look at it, right? I mean, so, and we can simply drag and drop the enterprise level style gates. I mean, if you look at it, the first one, right? I mean, this is definitely a firm-wide style gate which we have adapted for this. And second one, if you look at it, this is predominantly for this particular application level widget. We can clearly say that, right? I mean, it's a domain widget because this represents your, based off a health kind of stuff, right? I mean, so for that, what are all the different sub menus which are required for that? Those are all being configured. And if you look at the central part of it, that is where the captured widget from your transcoded application. This is the application level. And then the last one is definitely the trailer, which is again the footer part of it, which is again enterprise wide, right? And then now that's it. We have actually configured the Angular screen for it. And the moment we go and do a build, it automatically gets all your dependencies, and then it tries to launches it in a particular port. So now the good part of it, you don't really have to have a lot of people who are actually pretty familiar with Angular or React to work in this project. And then the second one is whether we have a data API, whether we have a data as a service or a microservice. This comes with a dynamic web bending. So in the backend, actually, whatever services which we have created from the previous step, especially the V functions they spoke about, right? Those things can be dynamically configured right here as part of the build itself. So they just start picking it up, and then seamlessly they also refer back to the deployed Spring Boot services are definitely going to get data from the databases like Yugabyte or PostgreSQL or MongoDB or those kind of stuff, right? So that is where it extracts the data and then it puts it back here. So we are seeing that this kind of a modernization, especially when you have, in one of the customer, when we look at it, right? They have like 1,400 screens, and then they are looking for a quick mainframe exit. So, how do we actually do the modernization? And this kind of a low-code, no-code platform helps us transform it into a practical manner. If somebody is just looking for UI or just the data part of it or just the services part of it, this helps in every nuances of it, right? And then this extraction will go for a couple of more minutes. So the other advantage, which I also wanted to talk about is, initially I spoke about the CQRS, right? Just offloading your inquiry services out of it and then modernizing your database also, as well as your UI, right? So in this case, there is no services modernization, but then the first and the third one are getting modernized, your UI and your data. So very much the first and the third one within our moderniZ offering can be leveraged here. Right? And then we see there is a large market for the CQRS, especially offloading the mainframe inquiry transactions. We see most of the large banks, financial companies and insurance organizations, retailers, and all moving towards this case. And we see the whole mainframe getting modernized as part of our, anytime when the overall consumption is less than 10,000 nits or those kind of stuff, people go for a big bang modernization where completely rip and replace their entire mainframe estate into the target landscape, where it is like, completely getting into your Spring Boot with Angular and other stuff, right? So these accelerators at your data level, getting your data objects, getting your schema, and then converting your sequels of it, and then creating all those things. It helps in every phase of it for the mainframe modernization assets. And while this is a big opportunity, we're all looking forward for it. And this will shortly launch the modernized UI, which we can quickly look at it. Yeah, it has just launched it in port 4200. You can quickly see that, right? The whole look and feel of the entire UI has completely changed. It's all completely menu driven. If you look at it, somebody do not have to type a NAM0 and then come back here. Rather, they can just go to customer and then they can, onboard NAM. When they click on it, automatically the screen should be coming up. So for the new generation people, if they wanted to do a screen-based navigation, this works. For the people who are used to the earlier one, if they still wanted to navigate it like, NAM0 or NAM1 based on the transaction type, or even based on the system type, action code, and key, if they wanted to do that, it completely works as is, right? So the same kind of navigation. And some of the native navigations, like, the back screens, the PF3 screens, those things are also being clearly mapped out here. So this is our story of the mainframe modernization. And if you look at it, these screens are like, web bound back to the Spring Boot application services, which have created from the function. So, and they're also going to hit from the cloud database together, right? So this is a quick story of, Wipro's modernization. Thank you. Thanks for your time.